Welcome to this screencast on proving that a quadrilateral is a rhombus making use of GeoGebra. Previously, we've talked about how to enter points into GeoGebra. We're going to take these points and make segments between them using the segment tool and connecting the points A to B, B to C, C to D, and D to A. We then wish to prove if this quadrilateral is a special quadrilateral of any kind. And we'd first like to prove that it is a parallelogram. So to prove that a figure is a parallelogram, we need to show that the opposite pairs of sides are parallel to each other. We do this with slope. So if we wish to measure a slope, we can select the slope tool and select segment AB, and it tells us the slope is 1.5, and the slope of CD is also 1.5. If these slopes are equal, then these opposite pair of sides are parallel. You should, of course, be able to calculate the slope by subtracting coordinates 2 minus -1, which is 3, and -1 minus -3, which is 2. So this slope is 3/2, or 1.5. Now the other pair of sides also need to have equal slopes and be parallel, so we'll also find the slope here, 0.67, and the slope here, also 0.67. So what have we shown? We've shown that this pair of sides have equal slopes, and therefore they are parallel. So we have shown that opposite sides have equal slopes so that the sides are parallel. Therefore, the quadrilateral is at least a parallelogram. So we know that we have a parallelogram. But we'd like to see if this parallelogram is even more special, and we would like to envision that perhaps all of these sides are the same length, and perhaps it is a rhombus. In order to prove this, we need to know the distance of each segment. So if I go to the distance tool, and if I measure this, I find the distance is 3.61. The opposite side, the distance is also 3.61. We actually already knew that. When we showed that a figure was a parallelogram in the last screencast, we proved that the opposite sides also were equal. So what we really care about are the adjacent sides, and we'd like to know, what about this side here adjacent to this one? And it's a little hard to see now, but if I move it, this side adjacent to this side is also 3.61. Since it's a parallelogram, that means the opposite side here must also be 3.61. I'll show that it is. So I have that all four sides are 3.61. But really, all I needed to show, once I showed it was a parallelogram, was that any two adjacent sides are equal in length. Now, of course, with pencil and paper, I would need to use the distance formula to find these lengths. So what have I proven? I've proven that adjacent sides of the parallelogram have equal distances, 3.61. And therefore, the parallelogram is also a rhombus, a special parallelogram. All right, lastly, I would like to know, is there any possibility that this parallelogram is also a rectangle? Well, if it were a rectangle, then these sides would have to be perpendicular to each other, and that would mean that the slopes would have to be opposite reciprocals of each other. We have a slope here of 1.5, or 3/2. We have a slope of this segment of 1. 1 is not the opposite reciprocal of 3/2. So these slopes are not opposite reciprocals. Therefore, these sides are not perpendicular, and thus this cannot be a rectangle. So again, the adjacent sides of the parallelogram do not have opposite reciprocal slopes. Thus, there are no right angles, and the parallelogram is not a rectangle. It's a rhombus. That concludes our screencast.